One aspect of living things that life scientists can look at is what makes them and what makes them unique. And one way they do that is looking at living things at the cellular level. So this lesson we're going to split up in kind of two chunks. The first little chunk is talking about the chemistry and atoms and molecules, and then the second chunk will actually be talking about important molecules in order to sustain life. So an element is a pure substance that cannot be broken down into other substances. We find a list of the elements on the periodic table. Compounds form when matter of two or more elements combine chemically in a certain ratio. So an example of a compound is NaCl, which is called, in your language, table salt, or everyday language. In the chemistry world, we call this sodium chloride. Another example of a compound is this image right here, which is water. And we know it's water because it has the one hydrogen molecule and then one oxygen atom and two hydrogen molecules for H2O. And then a molecule is the smallest particle of a compound that has the properties of that compound. So this is one water molecule. If we had a second image, that would make two water molecules. If we look at the table over here, we can see 8 different elements listed, and these are the elements that make up the human body. And so the human body is 65% oxygen, 18% is carbon, 10% is hydrogen, and 3% is nitrogen, and so on down the line. So let's say that an organism weighs or has a mass of 100 kilograms. That would mean that 65 kilograms of that mass is oxygen, 18 kilograms is carbon, and so on down the line. So in any human body, oxygen is the element that's there in the highest quantity. Atoms are the smallest particle of an element that still has the property of that element. They're extremely tiny, and you can only see them with an electron microscope. In the nucleus, we have two types of particles, protons and neutrons. And surrounding the nucleus, we have electrons. So protons have a positive charge. Neutrons are neutral in that they have no charge. And then electrons are negative. And so we're going to be spending the next couple days looking at atoms and how their structure and where these three particles, protons, neutrons, and electrons, are located. We refer to protons, neutrons, and electrons as subatomic particles. And we call them subatomic because they are smaller than atoms. And so we're going to take a look at this little worksheet here. And each of these squares represents a square on the periodic table. So this whole number at the top, we call that the atomic number. And the atomic number indicates how many protons an atom has. The O is the element's symbol. Oxygen is then the full name. And then lastly, we have the decimal number. And this decimal number is the atomic mass. And the atomic mass, if you scoot over here, is the number of protons plus the number of neutrons. And so when you see a number down here, what you are going to have to do is you're going to have to round it to the nearest whole number. So in this case, 15.999 would round up to 16. We can fill out over here the atomic number is equal to the number of protons and or the number of electrons. So now what we're going to do on this bottom portion is fill in any of the blanks. So if we look at this first one, we have an atomic number of 8, an element symbol of O, we have a blank where we're supposed to write the full name, and then we have our atomic mass. So the full name of the element O is oxygen. And then we need to answer these questions here. So it's wanting to know the atomic number. So if you look up here at your little chart, it tells you that the atomic number is that whole number. So we can write 8. Then it wants to know the atomic mass. And so again up here, points to where the atomic mass is, but remember, you have to round that, so that becomes 16. And then it wants to know the number of protons, which again is equal to your atomic mass, your atomic number is 8. And then your number of neutrons is equal to your atomic mass equals your protons plus neutrons. So if your atomic mass equals your protons plus neutrons, we can fill in. We know our atomic mass is 16. We know we have 8 protons, and now we just need to solve for n. And so we do that by subtracting 8 from both sides. And so then 16 minus 8, we have 8 left over, so that means that there are also 8 neutrons. The last piece is the number of electrons. And the number of electrons is also equal to the atomic number, which in this case is 8. So looking at our next example, we have a blank for the symbol. So the symbol for zinc is Zn. Our atomic number, again, is the whole number, so we have 30. Your atomic mass is the decimal number, but you have to round that. So 65.39 would round to 65. The number of protons equals your atomic number, so we have 30. Then we have to do a little math to figure out our number of neutrons. And we have this little formula, your atomic mass equals your protons plus your neutrons. In this case, our atomic mass is 65. We have 30 protons, and we need to solve for n. Do so by subtracting 30 on each side. And 65 minus 30 would be 35 neutrons. And then lastly, the number of electrons is also equal to the atomic number of, in this case, 30. So our last example over here is Li, and we can see we have a blank for the full name. Li represents the element lithium. Our atomic number, we look for the whole number at the top, is 3. Our atomic mass is the decimal. In this case, 6.941 will round to 7. Our number of protons is equal to our atomic number, which is 3. And then again, for number of neutrons, we have to take our atomic mass equals our protons plus neutrons. So we know our atomic mass is 7, number of protons is 3, and solve for n. Subtract 3 from each side, and n equals 4. So that means we have 4 neutrons. And our number of electrons is equal to our atomic number, which in this case is 3. So this is a brief introduction of atoms and protons, neutrons, and electrons, and then how to find some information on the periodic table about each of these elements.